Welcome back, everybody. In this video, we're going to go ahead and go configure DMVPN on the routers that we are going to configure it on. So in this topology, as you can see, we're going to be taking a look at DMVPN configured on iOS 22, 24, CSR 11, and iOS 25. And once we have all of this configured, the goal would be to go through and at least get DMVPN up and operational. And then I'm going to add in a little bit of the back-end config. We'll have to do a little bit of configuration on the switches here and the routers in order to get some of the communication to work. So by the time we're all said and done, we will have routing propagate. We'll have learned some routes, but not everywhere. And so we'll go through the process of getting some of the back-end stuff going and go from there. But that'll come towards the end, if I have enough time left. It may depend on how deep I've gone in my explanations and stuff like that. So without any further ado, let's go ahead and get started. So I'm going to go ahead and pull over Secure CRT, and we're going to go ahead and get started with our config. So we're going to start on iOS 22. iOS 22, the configuration is going to be relatively straightforward. So I'm going to go to Show IP Interface Brief. And as you can see, I have everything configured from a operations perspective. So we have what we need to have there. We don't have any routing enabled yet anywhere. That'll come later on. But I need to go to global config, and I need to go to interface, tunnel, and tunnel 1. Now underneath here, we could do a lot of different things with the tunnel, but what we're going to focus on is the initial setup. So the first thing we need to do is type in a tunnel source. In this particular case here, we're going to say the tunnel source is going to be gig 0/2 and gig 0/2. Now, the reason why I'm choosing an interface and not a IP address is if the IP address changes, because I don't know, maybe there's a dynamic address and I don't want to go and lose connectivity if the address changes. I want to be able to rely on the interface being there at all times. So the next thing I'm going to type in here is tunnel mode is going to be mGRE and then multipoint, and that'll bring the interface up. The interface is now up, and now I get to type an IP address. In this particular case, I'm going to type in 10.1.1.22 and /24. Now that's going to allow me to do this. Technically doesn't really matter at this point, but I'll be able to copy and paste the config into the other routers once they're squared away. So what I'm going to go ahead and do is now I need to specify the hub side NHRP configuration, which is going to be IP, NHRP, and then a question mark. We don't have a ton of command options, but there are a few. So as you can see here, we're going to be leveraging the network ID. Technically, we don't need that right now because we're only going to be running a single cloud or subnet over this particular router. But if we had multiples, we'd want to make sure we had multiples referenced. We are going to be specifying a mapping of the IP address to the NBMA and specify authentication. So I'm going to type in the map and then multicast dynamic. So anytime we get dynamically learned destinations from client registrations on the hub, we're going to go do that. The next thing we're going to do is the authentication. I'm just going to type in Cisco to keep it simple. IP, NHRP, network ID, and we're going to specify a value of 1. And that's it. Those are the main commands that we're going to need to leverage as we're going along. Other commands will be added later on as we're going along, which will be specific to the task. So right now we've got this configured, and we're going to do a show IP interface brief to make sure that we have the interfaces up and running. We're going to do a show IP NHRP, and right now nothing is there. If we were to look at the other variables, we could say the tunnel 1 and look at the detail. Nothing is here yet, right? So we actually have to go to the other side and configure it. So I'm going to go over towards iOS 24. iOS 24, I'm going to go do this, and I'm going to go to global config, interface tunnel 1. I'm going to type the tunnel source is going to be, let me just double check the IP, which interface I'm working with here, which is going to be interface to gig 0/0. So tunnel source is going to be gig 0/0. And I'm going to take the tunnel the tunnel mode is going to be mGRE multipoint. That's going to get us up and running. With that being said, I'm going to go ahead and configure the next steps. Now there's two different ways you can define the next hop server. There is the method I'm going to show you now, and then on the other routers I'm going to show you the cleaner way. It's one line of config versus 3 lines of config. So I'm going to type in the IP NHRP next hop server, and I'm going to specify the IP address of the next hop server, which is going to be 10.1.1.22, and I'm going to say NBMA. Sorry, that's all I have to type in there. And I have to specify the IP NHRP map, and the destination that I'm going to be sending this is going to be the IP address of the hub, so 10.1.1.22, and I can specify the public address, which is in this case here is going to be 122.0.0.22, and hit the enter key. I then have to specify the IP NHRP map, or I'm sorry, multicast map multicast, and the NBMA address is going to be 122.0.0.22, and hit the enter key. That was kind of painful. Do show run interface tunnel 1. We see these 3 lines of config, right? It's necessary to type them in if you don't know the command. I'm going to specify IP address. In this case, here would be 10.1.1.24/24, and that's I had to type in the IP NHRP network ID is going to be 1, and then IP NHRP authentication is going to be Cisco. Do show run interface tunnel 1, and these are the commands that I need to have in play. I'm going to go back over to 22. I'm going to hit the up arrow, and guess what? We have a registration. If I come up here, we have it up and running. If I do a show DMVPN, we have an active peering to iOS 24. So that's going to be the DMVPN aspect of it. Now, these commands are a little, it's a little outrageous because you have to type in the next hop server, then you have to specify you're going to map multicast to a particular IP address, and you're going to map everything to, you're going to specify your next hop for your IP to your public IP. It's a little laborious. So a cleaner way of doing this would be on CSR 11. Now it's not specific to CSR 11. I'll do it on iOS 25 as well. But I'm going to type in interface tunnel 1. I'll type in the tunnel source is going to be tunnel 1, gig 1. So tunnel source is going to be gig 1. The tunnel mode is going to be mGRE multipoint. And then I'm going to specify the IP NHRP, and then the next hop server command again, but I'm going to do a little bit different this time. I'm going to say the 10.1.1.22 is the next hop server IP address, but then I'm going to specify the NBMA address is going to be 122.0.0.22, and then I'm going to follow that up with multicast and hit the enter key. So it's a little cleaner than the other router. I'll type in the IP NHRP network ID is going to be 1, and the IP NHRP authentication is going to be Cisco. So with that being said, those are the commands that I need to have in play, and then I'll specify the IP address of 10.1.1.11/24. So I have that up and running. I'm going to go over to iOS 22, show DMVPN, and there I have CSR 11 has now been propagated. If I do a show DMVPN detail, we're going to see a little bit more information, but not too much more. We're in good shape there. Now the next thing we're going to do is go to iOS 25, and I'm going to go to global config, interface tunnel, do show IP interface brief. We're going to type in interface tunnel 1. The tunnel source is going to be gig 0/2. The tunnel mode is going to be mGRE multipoint. IP address in this case here is going to be 10.1.1.25/24. And the reason why I'm doing this ahead of time is because I can go back over to CSR 11 and I can do show run interface tunnel 1. And I can literally just copy and paste these lines of config out of CSR 11 to 25 and paste them in here. In this case here, I don't need this one. The tunnel source is wrong, but so now do show IP interface brief. Now the tunnel is down. So do show run interface tunnel 1. The tunnel source is going to be gig 0/2. That'll bring the tunnel back online. And now if I go over to 22 and I hit the up arrow, now I have all 3 routers have formed, which is what I'm looking for. And that, ladies and gentlemen, is the basis of what we're trying to accomplish here. So now we don't have anything going on in terms of routing or anything else. So could we add routing? Yeah, we sure could. So let's go ahead and do that initially over the tunnel. So we know what IP address we're going to be using. So on the hub, I'm going to go type in router EIGRP1. I'm going to specify the network is going to be 10.1.1.0, 0.0.0.255. That's all I'm going to type in. I get to type in do show history. Oh, I'm sorry, do show run section EIGRP. I forgot that iOS doesn't like to do that. So I'm going to grab those lines of config and I'm going to drop them onto iOS 24, iOS 25, and CSR 11. Okay, so now we have all these peering, so I'm going to go over to here. Now we have all these EIGRP adjacencies, right? I'm going to do a show IP EIGRP neighbors, and I have 3 neighbors. So what that means now is I get to go to the next step, and I get to go and configure the backside of the data center. So in this case here, I've already got some IP addressing done. All I have to do really is go through the configuration process of getting switch 3, switch 4, the switch, and then iOS 34 squared away. So let's go ahead and get that done right now, and then we'll be able to go to the next step of taking a look at the configuration for the other 3 locations and take a look exactly how that comes into play. So on iOS 22, I'm going to do a show IP interface brief. So I have that. So I'm going to go to global config and type in router EIGRP1 network of 10.3.22.0, 0.0.0.255, and 4.255. Then I'm going to go over to switch 3, show IP interface brief, and I have a bunch of devices up and running, or I should say SPIs up and running. I'm going to go to, actually one thing I'm going to do on 22 is network of 22.22.22.22 0.0.0.0. And I'm going to go down to switch 3, and I'm going to type in do show IP route to validate whether or not routing is enabled. Routing is enabled. So I'm going to type in router EIGRP1 and then network of 10.3.22.0 0.0.0.255. So that should form the adjacency with that, which it does. And then I'm going to go over to switch 4 and do the same thing. Type in router EIGRP1 network of 10.4.22.0 0.0.0.255. So that should form an EIGRP adjacency with that, which it does. So now 22 should have additional EIGRP adjacencies. Now I have that, so let's just go check over on 24, for example, and do show IP route. So am I learning anything in here? And I am learning routes. I am learning stuff that comes over the DMVPN tunnel, which is awesome, which means everything that I'm trying to accomplish has worked thus far, which is awesome. So now I get to go over to back to switch 3 and 4. So what I'm going to go ahead and do now is I'm going to create a VLAN on switch 3 and switch 4, which is switch 3 and switch 4 are running VTP, which should automatically propagate that to switch or SW, and that should learn the VLAN of 101, and I'll place it on the interface facing iOS 34, and then configure iOS 34, get a little bit of routing done on that, and once that's complete, I'll go through and that information should propagate down to the other spokes. So we'll get that configured real quick. So now on 3 and 4, I'm going to go back to switch 3. I'm going to come in here and do show VLAN brief. And I do not have VLAN 101, so I'm going to create VLAN 101. I'm going to exit out. VLAN 101 only because of the fact that we're at DC1 and 101 makes sense. We're going to go over to switch 4, do show VLAN brief. VLAN 101 is there. I'm going to go down to the switch, show VLAN brief just to validate that it's there. VLAN 101 is there. I'm going to do a show CDP neighbor. And in this case here, iOS 34 is not running, doesn't appear to be running CDP. Let's just validate that real quick. Show CDP. Oh, it is running. Okay. So show CDP neighbors. Let's go show IP interface brief. And I bet you it's an interface issue. Yep, it's an interface issue. So here, interface gig 0/0, I believe. Actually, in this case here, let's go check the physical topology, which we have available to us. I'm going to go ahead and pull the topology up. And in this case here, it's going to be gig 0/1 is what we're going to be looking at. So on gig 0/1 on here, so no shut it. And I'm going to give it an IP address. In this case here, it's going to be 172.16.101.34/24. So there's that. And I'm actually going to turn off IP routing on this guy. So do show IP route. Routing is enabled. So I'm going to type in no IP routing. Normally that would be a bad thing and you wouldn't want to turn that off, but I'll explain to you guys here in just a moment why I'm doing that. So back on 3 and 4, at least on here, I'm going to go in here. Now 34 is showing up, so I go to interface gig 0/2, switch port access VLAN 101, switch port mode is access, and spanning tree port fast. So that'll bring the interface up and running right away. Then I'm going to come back over here, and now if I look here and show interfaces trunk, I should have 101 is available on all these uplinks, which it is, which is what I'm looking for. Now on switch 3 and switch 4, I had to create an SPI. So I'm going to type in interface VLAN 101, and I'm going to specify IP address. In this case, here to be 172.16.101.3/24. And I'm going to no shut that guy. Do the same thing on switch 4. So interface VLAN 101. IP address is going to be 172.16.101.4/24. No shut it. Now that I have this done, what I want to do is I want to enable first hop redundancy, right? I want to make sure that regardless of which way iOS 34 goes, you can always get out. So let's go ahead and do that. I'm going to type in standby IP, and for this one here, it's going to be 101 for the group number. It's going to be IP of 172.16.101.254, which is going to be the default gateway. I'm going to type that in. I'm going to go over to iOS or switch 3, and I'm going to copy and paste that in right here, which momentarily we should get HSRP up and running. And then I'm going to go back to iOS 34 and type in the IP default. The default, in this case here, is going to be gateway, is going to be 172.16.101.254. Now you might say, Rob, why do you care? Well, now I have a gateway specified. So now I should be able to ping 172.16.101.254, assuming that 3 and 4 are now good to go. Let me just double verify that. Show standby brief. And we are currently oh, there it goes. So now we're good to go there. We're going to go to here. Now, switch 4 is the primary because he has the higher IP address. Go back to iOS 34 and then ping the address. And I should get a reply. If I do a show ARP, I get a 0C07, which I know is an HSRP MAC address, so I know HSRP is working. Now I get to go back to 3 and 4, and I'll type in router EIGRP 1. I'll type in network of 172.16.101.0.0.0.255, and I'll take these commands over here. T router EIGRP1 network of 172.16.101.0. There we go. So now that that's been propagated, I should be able to check. I have a routing protocol adjacency, which is awesome. Now, I'm not too concerned about reaching 34, right? I could, but that's going to come in a different time zone or a time in an upcoming video. So now that I've got that guy squared away, what I'm going to go do now is check iOS 25 to see if I have the route. Show IP route. And I should have the 172.16.101 network, which I do, which is awesome. Now, I should be able to go to Nexus 20 here. Go ahead and log into this guy, admin, and then the password. You can give whatever password you want. And I'm going to do a show IP route. And I have not learned anything. So let me go over to iOS 25, and let's do a show IP EIGRP interfaces. So EIGRP is enabled on the gig 0/1 interface. Show EIGRP neighbors. I have an adjacency with Nexus 20, and I do see from my connection here that I do have a connection to Nexus 20's route. So let me go back to Nexus 20. Let me ping 172.16.101.34. I can ping that from 25, which is awesome. If I come over here and do a show IP route EIGRP, let's see, it's not propagating here. I'm not too terribly concerned about it at the moment, but, oh, you know why? I know why it's not working. Because I had the wrong EIGRP, so actually that's my fault. So I didn't think about that ahead of time. If I do a, I look here, so the reason why it's not working, which is, I should have known this, is I'm running AS1 with iOS 22, but I'm running AS102 on, with Nexus 20. So I have to actually go and not fix it per se, but let's go to router EIGRP 1 and redistribute EIGRP 102 and hit the enter key, and then 102 and then redistribute 1. So now let's go back to 20, hit the up arrow, and so now I have all these routes. They're external routes, but that's okay though. If I ping 172.16.101.34, I'm able to get there all day long. So that works out the way that it's supposed to, and it's going over the DMVPN. So that works. So now I'm going to go back down to iOS 24 and do show IP interface brief. And I need to go to configure, let's see, interface gig 0/1, I believe. And let me just double check the web page. Gig 0/2. Okay, that connects to 18, no big deal. Go to 2. IP in this case here is going to be, I think that's 102, 103. 172.16.103.24/24. Let's go ahead and no shut it. And then we're going to go down to switch 18, which is right here. We're going to go to global config. We're going to create VLAN 103. We'll specify that, let me go turn on 33 as well. Interface gig 0/1, I believe. Just double check the physical aspect of this. gig 0/0, sorry. We'll no shut, and then type an IP address of 172.16.103.33/24. We'll no shut the interface. And what I'm going to do is we'll type in do show IP interface brief, interface loopback 0, IP address of 33.33.33.33/32, and then router EIGRP 1, network of 172.16.103.0, and then network of 33.33.33.33.0.0.0.0. So now we have to go back to switch 18. We'll go and create that. Do show CDP neighbor. And we'll type in interface range gig 0/3 through gig 1/0. And switch port access VLAN 103. Switch port mode is access. Spanning tree port fast. So there we go. And there we go. But only effective the interfaces are non-trunking mode. And they are in non-trunking mode. So now I go back to 33. Momentarily, these connections should come up here momentarily. So let me just show spanning tree VLAN 103. They are in forwarding. So let me go over to iOS 24. And we're going to type in router EIGRP 1, network of 172.16.103.0, 0.0.0.255, network of 24.24.24.24, 0.0.0.0. So now we have all that going. Now we go back to 33. I have an EIGRP adjacency. Do show IP route. I'm learning a bunch of routes that I need to have in order for connectivity to work. So that's awesome. That's working. And last but certainly not least, we need to go over to CSR 11 and do all those same configurations there. So show IP interface brief. We have gig 3 is already configured, so let's go to router EIGRP 1, network of 10.11.19.0, 0.0.0.255, and then on switch 19, which is way over here, show IP interface brief. We'll go to host name is switch 19, and then we'll specify that interface. Oh, I didn't have an interface created here. Not that big of a deal. I can create one real quick. We're going to say VLAN 19 or 104. I'll say 104. We'll type in interface VLAN 104. No shut it. IP address in this case is 172.16.104. I'm sorry, no, I need to do VLAN do show CDP neighbors. That'll help. Oh, you know what? CSR 11 is not running that. Let me just check the physical connectivity. So in this case here, we have gig 0/2. So I will go to interface gigs. I'm sorry, wrong router, wrong device, I should say. Interface gig 0/2, no switch port. And then we'll specify IP address. In this case here is going to be 10.11.19.19/24. Interface loopback 0, IP address of 19.19.19.19/32. And do show IP interface brief. We'll type in no VLAN 104, no interface VLAN 104, and then router EIGRP 1, network of 10.11.19.0, and network of 19.19.19.19, 0.0.0.0, And that's everything. Show IP route, we should be learning a bunch of routes, which we are. And the routes that we're learning are going to be routes from CSR 11 via Tunnel 1 to iOS 22. So we see this route right here, right? But what don't we see next to that? We don't see the 103 route. We don't see the 10.102.25. We don't see 20. We don't see 33. Why not? Because this is phase 1. Okay? Primary reason we don't see what we're seeing is because it's phase 1. So what we need to make sure we understand here, if we are to do a trace route to 172.16.101.34, sourcing from loopback, I can't do that here. Trace route 172.16.101.34. Source address is going to be 19.19.19.19. Let's do... Oh, you know what? It's doing a DNS lookup. So let's go no IP domain dash lookup. Let's trace route IP. And then that. And this again. If you don't want it to do a DNS lookup, type in yes next to numeric display and just enter all the way through. And it follows the path. So we are right here. You can see that it goes towards CSR 11, then it jumps over the tunnel to iOS 22, then it jumps down to, in this case here, switch 3, then it hits iOS 34. So we have end-to-end connectivity. DMVPN is working everywhere, right? So we're doing a very basic implementation of how this comes into play, and that's really what I wanted you guys to see. It's very, very plain Jane. Now, we could liven this up a bunch if we wanted to, but for right now, that's not what we want to accomplish. We want to be able to go through and get things operational the way that they need to. So if I go back over to iOS to Nexus 20 and do a show route, you're going to see a bunch of routes, right? But what we don't see is we don't see any of the connections from any of the other spokes. Let's say, why don't I see any of the routes from other spokes? Simple. If we go back to 22 and we look at the show IP EIGRP topology, what are we going to see? Well, we see the 33 route right here from iOS 23. We see Nexus 20's loopback address. We see the loopback of switch 19. We see all of that. But why is it not coming through? Split horizon. In other words, what's happening is all these routes are being learned from in on the tunnel from these other routers, right? So this route right here, this route right here, and this route right here are all being propagated to 22, right? They're all coming across the wire and they're all being learned, right? Now that's awesome, and they're being learned. So we see all these routes showing up in the EIGRP topology table, which means we'll show them most likely in the RIB, which we are, right? Now, in terms of how it's operating is the way that the split horizon rule comes into play is anything that's learned inbound on an interface cannot be re-advertised out that same interface because it might bring in a loop. So the idea is we're going to bring in the updates, but we're not going to send them back out the same interface. That's a split horizon rule. So this is a phase 1 issue, right? Now we can modify this in phase 2, which we will, and I've already covered that in the previous video. We covered how phase 2 comes into play and how it works. But again, it'll make, the reason why I spend so much time up front getting things to work, which really in terms of time is really not that much. But the reason why I have everything operational and we can see the routes is because of the fact that we went through all the trouble of getting it up and running. Now that we have it up and running, we can go and then focus on phase 2 and phase 3, and then the follow-on features, we can take a look at these operations and what they're actually doing. So we'll take a deeper look at phase 3 and how it comes into play, so on and so forth. So that's basically what you need to understand in terms of how all these technologies come into play. That's really the driver here. So that's what's happening. It's a split horizon rule that's preventing these routes from being propagated and learned, but from a spoke to hub communication and a hub to spoke, we are 100% good to go. And just to prove that one more time, let's go ahead and jump back over to here. We'll go to switch 3, for example. Well, actually, let's go from 34. Show IP route. We're going to ping 20.20.20.20. We can get there all day long. If we do a trace route to 20.20.20.20 and we do it numerically, guess what? We jump to router or switch 4, then we hit iOS 22, then we hit iOS 25, and then we hit Nexus 20. So, ladies and gentlemen, everything is working as expected with phase 1. So, is this a bad way to go about it? I would say no. It's actually probably one of the best ways to go about it, because in terms of preventing routes from going where you don't want them to, is a great way of doing things. So, but also this is a very generic way of doing DMVPN. But needless to say, it is being done. It is working. Until next time, guys, thank you so much for stopping by, and we'll catch you guys in the next video.